Alright, the next stop is element deterioration rates. Let's start actually with elements in general. Elements, which can be used in inspection, are defined on your element spec page. The default elements are defined by the AASHTO manual for bridge element inspection, but you also have the option to define custom elements, or agency-defined elements, sometimes referred to as ADEs. As I mentioned in an earlier video, if your agency uses certain conditions of certain parts of elements for decision making, like say B-mens, then it would be wise to define ADEs for those features and collect inspection data based on them. We also previously discussed the 4 condition states, also defined in the AASHTO manual. Just to recap, condition state 1 is the quantity in good condition, condition state 2 is fair, 3 is deteriorated, and 4 is poor or missing condition. Inspectors on site during their inspections input how much quantity of each element is in each condition state, and this inspection data is the foundation for all the optimization work that we will be doing in future. From the inspection data into the future, the software will need to model the deterioration to these elements, and each element will deteriorate differently. A bare concrete deck was going to deteriorate different from, say, painted steel beams, which will deteriorate different from wooden piers. So we need to input deterioration for each element. The element deterioration rates can be accessed in 2 ways. You can either go to Admin Modeling Configuration Element Specs and then click on the View Graphs button shown here, or you can go to the Admin Modeling Configuration Deterioration Profiles page. Clicking on that button is going to bring up the deterioration curve for that element. In this example, you can see that I've changed the median years of a concrete deck from 12.5 to 25 years. That's in the yellow at the top left. The solid blue line on the graph shows the deterioration of the currently saved values, and the dashed line shows the rate for the values entered above. Your agency will need to set these deterioration rates for all of your elements. We've done our best to pick defaults, but as an example, steel protective paint lasts about 15 years in Alabama's marshes and about 45 years in Utah's arid desert. So the deterioration rates should match the environment of your agency and your experience. If you need some help trying to set these values, some states have contacted Bentley to have us help determine what your deterioration rates should be. Just contact the help desk if you're interested in that. A good intuitive rule of thumb when setting these rates in the beginning is to look at when your element reaches 10% in condition state 4. In your mind, when you say a bare concrete deck lasts about 45 years, this is about the point you're thinking of. You can also see how protective systems would affect that deterioration. In this case, a 10-year wearing surface, approximately an asphalt treatment, is applied, and you can see that it extends the life of the deck for 5 years. Also notice that you can apply different environment modifiers to the graph to see the slopes for benign to severe environment conditions. And then each element can be assigned to the corresponding environment to reflect its specific deterioration. Some are in severe, some might be in moderate, low, and benign, or your agency may use these values to reflect mountainous conditions are severe and arid conditions are closer to low or benign. So collecting detailed element data and then setting accurate element deterioration rates are some of the largest impacts you can have on the quality of your optimized network results, which we will be discussing in a later video.